And last time we got some information about the structure of stem and the structure of roots. I need someone to tell me. In front of you here, we have some slides about the structure of plant and the structure of the stem. Who can tell me the xylem? Xylem composed of how many type of cells or how many kinds of tissue? The xylem, we said that it's composed of 50. Is it present in the xylem of plant? Show me your hand. No. It's composed of what xylem? Last time. 50 is fluid. Okay, and what? Companion cell. And finally we have what? Parenchyma cell. Okay? Well, what about the xylem? Composed of xylem vessels, tracheids, and parenchyma as well. And parenchyma. Okay? And then we see that we have about 4 theories. They discuss how the water can flow through inside the xylem vessel and tracheids. Number 1, the root pressure, inhibition, capillarity, and the last one that we going to start inshallah right now. Well, I need someone to tell me, what does it mean root pressure? Root pressure. It means what? If you bruise a plant like this one and try to cut the plant near to the surface of soil, you can see, observe exhalation of water in front of you, right? That's right? Okay. This theory is called root pressure. Called what? Root pressure. As a result of the continuity of the osmosis from the soil and the attraction water from soil reaching to its stem and to the rest of the plant. But we said this root pressure, or this theory, it doesn't explain how water can flow through or how water, the sap, can ascend through the xylem. Who can tell me why the root pressure, it doesn't explain the that water couldn't flow through inside the xylem? Because of what? We said that we have what? Some 3 reasons. The first one is what? It doesn't exceed pressure. Excellent. Number 2,
the context doesn't have root pressure.
Yeah, perfect. Like some kind of plane, they aren't supported by root pressure, and finally they are quickly affected by external factors. Okay, is it clear for you? Good. Thank you. The second one here, the inhibition and the capillarity. Right now I'm going to show you a video to understand how the water and fluid in a xylem work together.
Terms to describe these processes.
In front of you, I need you to imagine how the water came from inside one direction, from root stem till outside of the plant. Okay, through the transpiration process. Do you remember transpiration process? Why flying? Flying is what? The manufactured food, it is moved in 2 different sides. In front of you have the xylem, and that's why they manufacture foods like protein, other nutrients. Most of them are carbohydrates manufactured. And here you are, like in front of you, some microscopes includes these 2 slides, the fluid and xylem. That's what I'm talking about. The water, it flows in one direction from what? Root hair, xylem, root, xylem stem to the end of the plant. On the other side, you can observe that the manufactured food like carbohydrates and protein, whatever, they are can move in what? In both directions. Both what? Directions. Is it clear for you? Okay. Let's return back to what? To our theories. Again, we said that we have 4 theories. They try to explain how the water can flow through inside the xylem. We said the root pressure, it doesn't explain it. What about the inhibition and capillarity? Does inhibition explain how the water can flow through inside the xylem vessel itself? Does it explain? No, it doesn't explain. Why Arab doesn't explain that? what does it mean inhibition? In which of what? Excellent colloidal nature of some substances like lignite or so it doesn't explain because of what? Now, who can remember me that in the inhibition, I've told you something about the inhibition. The colloidal nature, it explains that water can move alongside the wall itself, not inside the xylem, inside the walls itself, not inside the vessels. Okay, so it doesn't explain it. On the other side, the capillarity is a very, very weak factor to explain how water can move through inside the xylem vessel. Because of what? Because capillarity, the capillarity tube, you know capillarity tube, which is diameter about 0.2, maximum 0.5 millimeter. Okay, so it doesn't explain because any capillary tube, maximum height for water that can go through inside it, 150 centimeter maximum. 150 centimeter. Then finally, we have what? We have the last one, which is cohesive and transpiration bulb. Well, the last one here nearly explains that. We have what? 3 kinds of forces. Cohesion force, which is the force among the water molecules inside it. In front of you here, the pathway of the water starting from the root here, then the xylem root, xylem stem to reaching the xylem in the middle of the leaf, then it gets outside of the plant through transpiration process. Okay, well, we're going to start with the